There are two specifications in terms of types of logs. The first specification is to say that there are primary logs and secondary logs. Primary logs are pre-allocated and secondary logs are the ones allocated dynamically as needed or as I use them. For example, let's take a look now at this other slide. Let's say I have one transaction which is transaction A. And it starts using this log. Then I have another transaction, say transaction B, and it also starts within this log. Now transaction A completes here, but transaction B continues here. And then it continues here and so on. Well, transaction A, it starts here and it finishes here. So it was a commit that finished, but transaction B continues. So that means I can't really reuse this primary log here because transaction B has not finished. I can overwrite this log, and we'll talk about circular logging later, where you may understand this better. Why we can overwrite this log, but anyway, in this case, transaction B has not finished. So if I need more logs because transaction B has not, I have set my primary logs to be 3, then I would need to generate dynamically another file which would be called a secondary log, and transaction B will continue here. And if transaction B still continues, then we have to use another file, another secondary file that will be generated. And then if for any reason transaction B still needs more logs, then I will get an error from DB2 saying that there are no more logs available. So the default behavior may be to get the error message to draw back the transaction. Now there are different parameters or many parameters that can help change the behavior of logs. You can also have infinite logging, for example, where you just log depending on basically the size of your disk and so on and so on, but this just explains to you further the type of logs. These are number of logs are determined by parameters. So for example, if I first connect to a database, if I connect to sample, then I can run the command db to get dbcfg. I don't need to put the clause for sample because I am already connected to sample database. And then since I have a grep command and I'm going to grep for the word log, and it's going to show me all the log related parameters. So for example, I have the log buffer size. This is the size of the buffer for the logs, log file size. So this is the size of each the files, which is 2004 KB. So the unit is kilobytes, so 2000 times 4 KB, so it's about 8000 KB or 8 MB for each of these files. Then their log primary. This is the parameter that tells me how many logs are going to be primary. In this case, there are 3. And then log second, how many secondary logs will I generate dynamically? So in this case, it's 2 that will be generated dynamically, which is the default. So these are the default values for log primary. We'll see this example here matches that we have 4 log primary and log second, 3 primary key and 2 secondary logs. And we can also see here this parameter called new log path, which is pointing to, so if I go to the directory, I can see here the 3 primary logs, but I will not see the secondary logs because these ones are going to be created dynamically when I need them. One way to specify a good size for the log primary would be to monitor your workload and determine when or how many secondary logs are being created, and say 4 secondary logs are being created, and then you may want to add those 4 secondary logs to log primary. So you know, because it's not good for performance anyway. So that is one specification for logs, primary and secondary, and the other specification is active logs. And active logs are logs whether the information has not yet been externalized, meaning it has not been written to the table space. Logs are the ones where all the information from those logs have been externalized, meaning the table space has the up-to-date information, and this is going back to the previous example. About when we are updating from Peter, Paul, and Mary, when Mary, which was the last in the table, is ready to be externalized, and its log. Moving on to the next slide, now we are going to talk about types of logging before we talk about types of logs. Now we are talking about the type of logging, and there are two types of logging. We have circular logging and we have archival logging. And so circular logging means the existing log, so this would be used normally in test or development system. And because you are going to be reusing logs, basically the archive logs are the ones where the information had already been externalized. So those ones could be overwritten because you know the information is already in the table space. This, so I don't really need those logs, could overwrite those logs, and that is the procedure that is used in circular logging. Now the problem with this method would be when there is a human error. Let's say you input incorrect information into the logs and now you have overwritten those circular logs, then you have a problem in that situation because you can't go back to those old logs to get the correct information that you had in there. We are going to talk more about this in the next few slides. And get rid of any of these logs. You don't overwrite any of these logs, you just store them maybe in a different media. So circular logging, again, the way it works is that you working with log primary, another log primary, and let's say if this information in P1 in this primary log has already been externalized and I don't need this information anymore in the log because it's already externalized in the table space this, then I can potentially overwrite from this log. And the same thing again can overwrite whatever has been already externalized. Even I can go P1, P2, P3, S1, S2, and let's say P1 now the information has already been externalized, then I can go again and reuse it. So it will be, it's called circular logging, and again it will not be good to use in production environments. We'll talk later about crash recovery and basically archive. Logs are not needed for crash recovery, so they could be overwritten. Now let's now talk about archival logging. In archival logging, also known as log retain logging, the log files are not overwritten but are kept either online or offline. Online archive logs remain with the active logs which are still needed. For crash recovery, offline archive logs are moved to another media such as tape, and this can be done with user exit routines, Tivoli, storage manager, or other third-party archival products. To enable archive logging, set the database configuration parameters log argmet1 or log argmet or both to a value other than off. Another way to enable it is to set the log retain configuration parameter to recovery. This will automatically cause log argmet1 to be set to log retain. However, the log retain parameter is deprecated and has been left mainly for compatibility with older versions of DB2. Archive logging is normally used in production system because the logs are kept. This allows for database recovery back to point in time as early as the oldest log file. With archive logging, a DBA can recover from errors caused by humans. For example, if a user of a system inadvertently starts performing an incorrect transaction that lasts for days. Then, when the problem is detected, the DBA can restore the system back to the time before the problem was introduced. However, there may be some manual manipulation required for the transaction to return correctly. Archive logging is required for roll, forward recovery, and online backup. The figure depicts the archive logging process. Infinite logging is possible if you set log second to a value of -1. However, this is not recommended as you may run out of file system space, and it's not good for performance in case of a crash. To set up and configure logging in Data Studio, simply click on the database name and choose Setup and Configure Database Logging.